So in our short time together, I want to give you a glimpse into the X Moonshot factory, in particular how we fail gracefully on the way to success. And I will also talk a little bit about why we need the most diverse and brightest minds to work on building the future together, especially when it comes to new technologies like artificial intelligence. Okay, so at X, we work on projects like this: self-driving cars, delivery drones, smart glasses, smart contact lenses, now part of a company called Verily, internet from stratospheric balloons, energy storage using molten salt, and synthetic fuels by extracting CO2 from seawater. Now, the New York Times actually reported that we're working on a space elevator. That's not true, and for the physicists amongst you, you probably agree with me that it probably still breaks the laws of physics, but people keep pitching it to us, so maybe one day. So you might ask, what draws these very disparate projects together? And this is it, it's our mission. So we want to invent and launch moonshot technologies that make the world a radically better place. So we want to solve very large problems in the world with the help of technology, and we want to build meaningful businesses for Alphabet in the meantime. Now, what's a moonshot? This is our definition. We start with a huge problem in the world, something that might affect hundreds of millions of people or even billions of people if it was solved. Then we propose a radical solution, something that today sounds like science fiction, but we think that there's a breakthrough in science or technology on the horizon within the next 5 or 10 years that will help to turn that science fiction into reality. So that's a very simple concept, right? But of course, it's not that easy in practice. And that brings me to the failure part. So the path to success, in my experience, is littered with failure. I've had plenty of them myself. And in fact, the more audacious you endeavor, the more likely it is that you will fail. And I grew up here in Germany, where that is not necessarily something to be proud of, right? It's not part of the culture here. And so we would look enviously across to Silicon Valley, where even the failed people would be celebrated as heroes, or so we thought. Now I've lived there for 6 years, I can tell you that's not true. It's one of the great myths about Silicon Valley. Everyone there also aims for success, and everyone always tells you that their startup is going really well, and every investor always tells you that they've just invested in the latest Google or Facebook or Slack or whatever it is. But I think what's perhaps different is that people are better at not being afraid to fail in the first place, so they're not put off from trying, and when they do fail, they bounce back faster. So I think there's something to learn there. And I actually think that fear of failure is perhaps the biggest impediment to innovation, much more so than lack of funds. And that's because fear of failure is a real existential fear. We're afraid to lose face, we're afraid to lose pride, our bonus, our promotion, our job, or even our company. So I lead early stage projects at X, and I've worked in startups for most of my life. So many of the projects in my group don't go forward, or they pivot in very unexpected ways. So I'm constantly thinking about which projects do we start, which ones do we advance, which ones do we shut down, how do we decide, and how do we make it safe for the team? How do we create psychological safety in an inherently very unstable environment? So I still don't have all the answers, but here's some of the things that we've learned. So the first one is, we have to accept that we will fail. Now, this is often attributed to Edison. I've not failed, I've just found 10,000 ways that don't work. He probably never said it, but it's a great quote. And so that really is about expecting that most of what you're going to do won't work. And at X, we never aim for perfection on the first go, because we know that's futile, so we learn as we try things again and again. And I actually think that's a useful reframing. So instead of saying we're trying to fail fast, which frankly is nonsensical, we should try and learn as fast as possible. And that means actually running at the hardest problem first. Imagine you want to teach a monkey Shakespeare or Goethe, to recite Shakespeare or Goethe while they're standing on a pedestal. what do you do first? Do you train the monkey or do you build the pedestal? Now, it's incredibly tempting, and most of us will be drawn to building the pedestal. But there's no point building the pedestal if in the second part of your project you encounter a problem that you can't solve. So you have to force yourself to tackle the monkey first. Let me give you an example from X. Loon was the project that got me to X 6 years ago. I was very happy living in London. I did not want to move to California, to a suburb called Mountain View. And then I heard about this project. More than half of the world still don't have access to the internet, and especially in remote and rural and poor areas. So what if we could have a network of balloons that floats 20 kilometers high up on the edge of space, that's connected to, the balloons are connected to each other, and they beam the internet back down to Earth. It sounds crazy, right? That's, by the way, why it's called Loon, and the team call themselves the Loonies, because they lent into that. Now, to make this work, the team had to solve many technical challenges, for instance, connecting the balloons to each other, connecting a phone down or radio down on the ground to something 20 kilometers up. This was our first prototype. It's a styrofoam box with some electronics inside it, and they strapped it to a leather balloon, and they sent it up to space, and they found that, yes, you could still get a connection from 20 kilometers up. I'm showing you this partly because all X projects have very humble beginnings like this. But one of the unexpected problems was that we had leaks in the balloon skin. So the helium was seeping out, and the balloons kept coming down rather quickly. I did the first business case for Loon, and we calculated that the balloons had to last 100 days. Our first balloons lasted 5 days, so we were definitely a long way from perfection. The leaks were the monkey, and nothing else mattered until we had solved that problem. So we set up a leak squad, led by Pam. Her job title is Head Balloonatic. And they studied lots of products where leaks mattered, like chips, packaging, and sausage casings, and even condoms. They ran helium detectors onto the balloons. They ran lots of experiments. Many didn't work. But one of the things they realized was that the manufacturing process made a really big difference, because people were walking around on the balloon material during the manufacturing. So they did a line dance with some normal socks, and they found that it was more damaging to the material when they used fluffy socks. So they said only fluffy socks are allowed in the balloon factory. And that's, of course, a bit silly, but we had to change the manufacturing process quite substantially. Back in the lab, they built a huge light table called Billie Jean. And in this lab, you're also famously only allowed to wear shark slippers. Now, the third thing we had to change was the way that we launched the balloons, because they were manual launches, and so sometimes the material would drag along the ground, which you can imagine is not very good for the balloon. And so now we have a fully automated balloon launcher, which is affectionately called Chicken Little, because I don't know if you remember that film where the chicken launches themselves far, far away. So in the past 6 years, we've flown more than 30 million kilometers of test flights, and one of our balloons actually survived 198 days in the stratosphere. So we hit our goal of fixing the leak problem. And working with mobile phone companies, we can now connect consumer phones at LTE speeds. So last year, we got a real test when a hurricane hit Puerto Rico and destroyed almost all of the infrastructure on the island. We actually launched balloons from Puerto Rico, so we immediately said we wanted to help. And so we worked with the local government and with AT&T and T-Mobile to restore connectivity, and we served about 250,000 people LTE speed internet for about 6 months until the network was rebuilt. So the Loon team learned a ton by being out in the real world, and is now getting ready to serve their first commercial customer, which is Kenya Telecom. So Loon, I would argue, is one of X's successes, but of course we had many, many failures. One of the hardest things for an entrepreneur is to figure out when to call it quits, because most people define only success criteria at the beginning of a project. So what we do is we also set kill criteria. What would make you shut the project down? What are all the reasons why it might not work, both on the technical and the business side? And when these kill criteria hit, it's a much less emotional decision to shut the project down. So let me tell you the story of one of my favorite projects. It was called Foghorn. And the goal was to make carbon neutral fuel by extracting CO2 from seawater. And then we made use clean electricity to make hydrogen. We combined the two to make a synthetic fuel that you could burn in any car. I love the idea because there's over 1 billion cars in the world that are not going to be electric anytime soon. And what this did is create a carbon recycling, effectively, because when the fuel was burned, the carbon was released, but because you'd pulled it out of the sea in the first place, you were not adding any more carbon. So the team figured out how to solve many of the technical challenges. This is our lab at Xerox PARC, who are our partner on this, and the bucket says ocean, so that's the ocean water going in, and then on the right you see Kathy Cooper, who was the project lead, and she carries a small vial of sea fuel. But we also set a goal to make it economically feasible to sell the fuel at the same price as conventional fuel. And you can probably guess what this is. It's the oil price, right? So we started the project $100 a barrel, and when the oil price hit $30, the team came to me and said we should shut this down. We can never make this work. So for this decision, I gave them a bonus, and they shared all of their analysis with all of X, but then they also wrote 2 papers that are now published in peer-reviewed journals so that other people can so see our cost model and our method. And there's a Harvard business case study on it. Now, I like to think this is a deep frozen rather than a dead project. You know, maybe there'll be realistic pricing of carbon one day that will make it feasible. You know, maybe somebody has an idea that we didn't have. But what was important about the story is that we were celebrating the lessons from this failure, and we rewarded the team for it. So we're making it possible for our teams to be honest with themselves, and we work to reduce that fear of failure. So we recently had an all-hands where all the stories that were told were failures and lessons from failures. We've decoupled individual promotions from success. So you can still get promoted for doing really good engineering or scientific work on a project where the project fails. Now, we also help our team members find new roles if the project fails. And all of these are very rational methods, but of course there's always an emotional side too. Humor can help. We have a team that works at the very early stages of projects. It's called Rapid Evaluation, and they shut so many things down that all they get is a little sticker with a crumpled piece of paper. But they now display them proudly on their laptop, and to have more stickers is actually a good thing in that team. But there's undeniably, of course, a dark side. And my degree is psychology, and there's this model of how we grieve when a loved one dies that was developed by Elizabeth Kubler-Ross in the 1960s. And I don't mean to compare business failures with the loss of a loved person, but it's really striking how our teams or how entrepreneurs whose startup shuts down are going through similar phases. So there's the shock and the anger and the denial, which you can reduce if you have things like kill criteria. But there's always still depression before you eventually come through to acceptance. So giving teams time to grieve is something that we found is really important. Now, to end this section on a lighter note, I want to remind you of what it was like when you learned to walk, right? When we fell over many times and it was not seen as a problem. So what happened between that time when we were toddlers and we just tried again and again to now when we think failing is a bad thing? Maybe we all have to go back to toddlerdom a little bit, but hopefully minus the tantrums. So now that we know how to fail gracefully, let's talk a little bit about how we might want to succeed. So the first one here is that we need to fall in love with the problems, not the technology. And technology is really just the tool, not an end in itself. We work on projects that often sound like science fiction when we first propose them, you know, like cars that drive themselves or automated drones and internet balloons, etc. And many of our projects have their seed in academic research. And that's because, of course, you're amazing at bringing about these breakthroughs in science and engineering. But when a paper is published, it's often not clear how it's going to make its way to market. And that's why we love science-based startups like the ones that just presented. So we can come in at this stage and take a prototype out of a lab, evolve it further, de-risk it further until we can convince a partner in an industry to partner with us to actually take it to market. So in the early 2000s, there was 2 universities in the US that were fiercely competing in the robotics space of autonomous cars. So you had Carnegie Mellon, who won one DARPA challenge, and then you had Stanford, who won the other one. And they actually came together at Google to build an autonomous car. Fast forward, and this is what one of our cars sees when it's driving along. It's essentially a robot. And it's enabled by a huge range of technologies that have made a lot of strides in the last 10 years, like computer vision, image processing, mapping, but also just storage. The fact that we can store all this data in the cloud and process it, and with cutting-edge machine learning techniques. So now it's possible for a car to drive better than a human. But initially, our car wasn't driving better than a human. It could only drive motorways. So the driver had to be ready to take over at any point when the machine couldn't handle a situation. So we gave this test car to 10 people outside the team and said, use this in your daily commute. And what we actually learned was that as soon as the car was in self-driving mode, people stopped paying attention. They were doing their email, they were daydreaming, they turned their back to the windscreen when the car was going 60 kilometers an hour. And so we realized that humans are not a very reliable backup, and that the machine actually would have to be able to drive in all situations. So we've pivoted from building semi-autonomous to fully autonomous vehicles, which meant a lot longer time to market because level 4 autonomy is significantly harder. But this is the Firefly, which was a prototype that was the first fully autonomous car. It doesn't have pedals, it doesn't have steering wheels. It does have wing mirrors because that was part of the regulations. And in 2015, the regulator said, well, where's the steering wheel? And we said, it's not in the regulations. And they said, yes, it is. And we said, no, do check. Anyway, so in 2015, a man called Steve Mahon, who's blind, took the first ride in this car. So it's clearly driving by itself. And now Waymo is in Arizona serving their first real customers. And that's a real car. It was built in partnership with Fiat Chrysler. And the reason it's a mummy van is because families with lots of kids actually wanted self-driving cars more than anyone else. So we listened. So our technology is very much shaped as it makes contact with the real world through forces as diverse as physics and biology, but also culture and economics. And that means we have to take our projects out into the world even when they're not quite ready yet. Now, glass is a good example of this, where we did lots of iteration in the lab. The team built a new prototype every 4 to 6 weeks, which is very fast for hardware. And then they finally took out this prototype into the world and tested it with real people. It was firefighters and surgeons and chefs and fashion models, all walks of life. And they gave us lots of feedback, like the battery life sucked, and the voice-enabled UI wasn't great because voice in 2012 was not that good. And they also gave us feedback on the use cases. And the consumers found that being able to take hands-free video was cute, but not that useful, that you'd want to wear a computer on your face that basically made you look really, really strange. But it was different in a B2B environment where people quietly started using it in factories, for assembly lines, in warehouses, and doctors to access patient notes. And it turns out that if you're an engineer assembling a Boeing 747 where the manual is this high, being able to get a snippet of the manual just when you need it is actually useful. So now it's pivoted to B2B. Now, this is something we could have never predicted if we'd kept it in the lab earlier. So even though the harsh feedback we got was tough to receive, it was definitely the right thing to do. So making a prototype, taking it out there, and taking the feedback is definitely always worth it. Now, that brings me to the final part of my talk, which is the people behind this. Now, Alan Kay was a computer scientist at Xerox PARC in the 70s when they invented pretty much everything from the mouse to the Windows UI. And he said the best way to predict the future is to invent it. But the myth of a lonely genius inventing is just another myth, right? Like the greatest inventions don't come from great men, they come from great teams. So technology, especially today, really needs to reflect the people that are going to use it. And that means harnessing diverse perspectives when creating it. So at X, our teams are highly multidisciplinary. They're hardware engineers and computer scientists that rub shoulders with biologists, but also with designers and lawyers and business strategists and storytellers. And they're very varied backgrounds. Some come straight out of PhD programs, out of university, but we also have army veterans and fashion designers and makers and artists. So a common misconception is that technologists are all engineers. I'm not an engineer. I did philosophy and neuroscience. And it turns out I'm very good at translating between engineers and the real world, and that's a complementary skill to engineering. So I would describe myself as a technologist, even though I'm definitely not an engineer. So I would argue that to solve the world's largest problems with the help of technology, we actually need a diverse set of minds to come together to work on creative solutions. And this multidisciplinary approach is especially important when it comes to AI. Fei-Fei Li said this. She said, "No technology is more reflective of its creators than AI." She's a computer science professor at Stanford, and she runs the Stanford Artificial Intelligence Lab. She's also one of my heroes. If you can ever see her talk, it's amazing. And she's an advocate for human-centered AI, which means three things. So the first is we have to build AI technologies that are inspired by the versatility and the depth of human intelligence. And that means that we have to reconnect AI with fields like cognitive science, psychology, and even sociology. Second, we have to build AI technologies that enhance humans. For example, smart robots helping with elder care. How the humans interact with the AI is really important. And of course, some jobs like drivers will be eliminated altogether, but the vast majority of jobs will just be changed. So there's a really great report that the McKinsey Institute did about a year ago, where they showed that over 60% of jobs will be affected by about 30% of the tasks within that job can be automated, but very few professions will be eliminated altogether. So we will all be working with robots and AI for years to come. Finally, we should be guiding the development of AI at each step with concerns for the impact that it has on society. So that's not just the impact on jobs, but also, for instance, bias against underrepresented minorities in machine learning, and also managing the tension between AI's ferocious appetite for data to feed it and the privacy rights of the individual. So it's clear that to do this, we don't just need computer scientists and engineers, but all sorts of disciplines. So we're living in modern times. People have always approached new technologies with a mixture of pride and trepidation. And in our age, I think the only thing that has changed is the pace of innovation has sped up. So we have less time to get used to them as they hit us, compared to, say, the age of the printing press or the age of the telephone, where people had centuries or decades to get used to them. So this relentless pace of change certainly creates uncertainty, but we do have the power to harness technology as a force for good. This is a list of the biggest problems in the world that was compiled by the UN. There's so many unsolved problems here where technology can contribute. We're working on some of them, like transportation and climate change and communication. And technology clearly is not going to solve all these problems by itself, and it's also going to create new ones. But it's up to all of us to determine how we can use technology responsibly to make a better future for ourselves and for generations to come. And I hope that many of you and many of your students will help us in this quest, whatever subject they're studying and wherever you're from. So I'm going to close with this, a quote from another one of my favorite women, Eleanor Roosevelt, and she says, "The future belongs to those who believe in the beauty of their dreams." Thank you very much.